I'm very happy to be able to introduce our guest speaker today, Dr. Radian Bilou from Drexel University in the Electrical Engineering Department. Dr. Bilou is here interviewing for the Electrical and Computer Engineering faculty position. He is an expert at power and power electronics, an area which I think will help us greatly in our teaching here at Fairfield. And today he's going to tell us all about one of the sticky points about green power, and that is microgrids. And so I would like to thank you for coming, and Dr. Bilou, take it away.
First, thank you to coming to attend my presentation. My name I'm Radian Bilou. I will present some of my research that was related to microgrids and distributed generation. So, microgrid, even we do not have an well accepted or universal accepted definition and a standardized definition. It's a collection of microsources distributed generation, usually controllable loads that are connected together. They can operate in like in standalone or insulated mode of operation that are disconnected from the large grid, or they can operate in connection with the grid. The most critical issues, it's the power management, control and protection, and special protection, because the classical protections that we have in a traditional grid are not working due to the fact that we have variable, non-dispatchable energy sources inside the microgrid at a scale that is larger than the traditional grid. So, I will start, so that is my outline of the presentation. I have a very short introduction. There are some, I have quite a few slides. For some of them I'm going a little faster because they are not so critical. I will discuss a little my research in protection and control for microgrid and some conclusion on future work. So, while there are the reasons that we are moving to smart grid, and to include in that, it's believed that, or many researchers, that one of the vehicles to implement the future smart grid will be microgrid. There are environmental issues, so in terms of reduction of the pollutant emissions, replacement of the old infrastructure, the regulatory, the paper process. It's a very long and it's with a very uncertain end up. So security of the supply and reduction of dependence of the foreign countries each other, to improve the quality of the service, because we are moving in the 21st century and we want to have, and we like to have a better quality service. There are also issues with the market liberalization, so we are moving step by step from a utility that are dominating an area to a free market. And there are also issues with the increase of renewable energy. How I mentioned, they are not dispatchable, so you don't have a wind energy generation when you would like to have that, or to increase that generation at a different level. So you need to collect that when the wind is blowing, or during the day for solar, and so on. The distributed and dispersed generation, there are units, and we want to increase the overall efficiency of the power grid, which is very low. So it's in the range of 27 to 30% from one end to the other end, from the generation end to the user end. There are also, to increase, and will be the participation, the demand side participation. Right now the consumers are passive units in the process, so only the utilities and the grid will decide what they are doing. So there are the reasons that we are moving. That was the traditional power generation, so we have the power flow in only one direction, the control of everything, protection and monitoring its shape and is designed for such systems. So we have quite a smart, if I name that, in generation and transmission, much less in the distribution side of the power grid. So what we are mentioning is we want, and my work was especially in that area, so to expansion of the grid compatibility with the renewable energy, communication between the grid and the different power supplies and power units and so on, and to have a much more control in that area. So the smart grid is believed that we can have the control of the power by means of information technology, computer and monitoring. We have from present day that it's in most of the grid from 1 to 3% of energy storage probably will increase with a level of 10 to 20% in the future. So there are several reasons to increase that. But they say there are a lot of technological challenges and issues. So that is what we have for the transmission systems, is what we want to integrate, what we have. So technical smart grid in the future, it's a merging between a power system, traditional power system, and a communication system having bidirectional power flow and information flow. So that functions that must be included in the system. So that is what we have. So we have the red for power supply and the blue for information. That will be. So what will be the system will be. We have flexibility. Will be much more efficient. We have monitoring and we have everything in real time. So if happens something in one section of distribution system, we are able to monitor, to localize, and to take care and to fix that problem in much shorter time, more efficient, and using less resources than in the present day. So the system will become more robust and resilient than it's the present day system. So that is what we have for future power systems and what we like to include, and that will provide the shape. And it started to be in some areas, in some parts of the states. I used to work for Nevada, so Nevada Power is starting to have the solar and wind energy quite an extended scale. So, how I mentioned the benefits and the characteristics of so we'll have reduction, so the system will become more robust. How I mentioned, we have a much better quality in terms of power that is critical for sensitive electronics or for some critical loads like hospital banks and banks, military facilities and so on, will be an integration of renewable energy sources, control system, and also storage option on much larger extent. We have to move to the smart home and so on. So we have other products that are not really my area of research, like service market and so on. So energy trading that we have in the future. So that there are the essential functions for smart grid, and the attributes that are more important that we mentioned. It's information-based communication, it's secure self-healing, so we have a resilience, so that will improve the quality of the service and will avoid any long blackouts and so on. So it will be much more flexible, the reduction of the cost, and everything will be controllable from loads to not only from generation, transmission, but also in distribution and at the consumer level. So the importance of introduction example for energy storage is that we can deal with the fluctuations. This is a profile example for a photovoltaic array or module during a day. So we have that fluctuations. So we need, example, short-term ultra-capacitor or some other type like flywheels that are power buffer to shape the fluctuations. Here we need also energy, what is named like batteries or other type that we provide energy during when the system is not working, because that will be to have that, we need to have the communication, we need to have participation of demand side, and a different way that we have control and protection, and we'll discuss a little later about that. So, we are right now mostly in what is named Smart Grid Point 1, so in terms of that, when we are moving to have the smart metering and collecting the data. So we are moving probably in the next five years to the Smart Grid number 2, that we have advanced autonomous control, distributed energy storage, much larger includable distributed and dispersed generation. So the system will be more like the internet today. So if you have power flow breakdown here, so you can use the other way to transfer power from other sites to that area that is affected by the malfunctions in the system. So that's what I mentioned here, so I will move. So that there are, who is not familiar with some definitions for what we name and what we have in the terminology, and we start up for distributed energy resources, distributed power. They are mostly in the range up to 100 megawatts. So, mostly they are operating in the range of 5 to 25 to 50 megawatts in that low power range that we have. So what we name dispersed generation is that we have power sources located to the consumer, so we reduce the stress on the transmission line, and we reduce the cost and increase the overall efficiency of the system. So that there are distributed resources, what we have and what we include. They are not only the wind, so we have the combustion engine, micro turbines, photovoltaic, solar thermal, low head hydro, so micro hydro, small hydro power, geothermal, and so on. The most other important will be the storage, so we'll add more storage to the system that is in the present day. So the drivers are deregulation, price volatility, environmental, power quality, reliability, and robustness of the system, and also others are development, technological developments, like the progress that we have in IT technology, computing technology, and so communication technology.
Is it okay if we ask questions?
Yes.
What does SMES stand for?
It's storage that is based on the superconducting systems.
On the what?
Superconductor systems. So it's similarly used, probably will be used like a supercapacitor for what is named power buffer, so to shade the fluctuations, small scale fluctuations in the system. So you can ask him questions all the time, so it's not a problem. Cool, so almost good. Here, so that are what I discussed for distributed generation, and one of the most important critical right now is to have advanced sensing and measurement. So most of the many areas still the distribution system do not have a real-time monitoring, so that is the most critical, and when there are the most issues with the power systems are in that areas right now. So, we are moving, this is the frequency and the cycle, so we are moving from a very high frequency right now in terms of smart grid here. So, and that is one issue is the control and the protections that we can have here. So, how I mentioned microgrid definition, so it's a power system so that we have distributed energy resources, we have storage, we have load, and it's believed that will provide maximum efficiency for the system, so, in that area. I will mention so that the smart microgrid will integrate that systems, and we have also the new storage control and protection. I will move a little faster to my area when I done that. research. So we think that, and actually the microgrid is not a new term or a new concept. So the initial electric grid was in the form of microgrid. So a city like Philadelphia, which was one of the first city that used on the extended scale electricity, they have power generation that was DC for one area, AC with 120 volts, AC with 220 volts, and from one street to others. They provide also heat and hot water for buildings and apartment buildings. So the system was a little more efficient than the present day one. So when we have a very large power units, we transfer the entire power to the user, and we have losses at power generation, losses on transmission, like in distribution system, and the losses and nothing is basically recovered, because it's very hard to transfer from 1 or 200 or 300 miles heat or hot water to a major city. Most of the generations are in remote places, very far from such areas. So that is how I mentioned. So we need to take through the control, all that we have here is landing separation, voltage regulation, frequency overload corrections, and so on. So there are a lot of challenges we apply that, starting from interconnection standards. I mentioned several times protection, control, operation, and management, metering and monitoring that we need to move to that, and communication and information. The other are not so critical, but still like public acceptance, stability of the network, and so on. So pricing for renewable energy, because some of them right now the price is not the real one, because they still receive price break subsidies from the local, state, or federal government. So that is one issue also in the future. So the benefits I mentioned. So we have embedded and distributed energy resources. We have advanced storage, we have more reliable and efficient and additional service for our consumers. Consumer participation, so the consumer can set how it uses the electricity, and probably will be based on a different, like in some areas or like some European countries, based on the different prices during the peak hours, during the night, during the day. So a more flexible demand that reduces the stress on the transmission system, so that there are some benefits. So how I mentioned, so we have different classes that are not yet standardized, like a single facility, multiple facilities, substation, feeders, and so on. It could be for one building, could be for a set of campus or military facilities, or for an area or a rural area or a small cities, and so on. So it's not yet very well defined in terms of how we categorize and classification of smart grid and even the definition. So that are the summaries and the most important. So we have demand response support, we have communication, sensing and measurement, smart meters, smart load. Some of them are technical, they are already in present day power system that will be adapted for that microgrid facility. So they have different architectures in general. They are shaped to the local conditions, and that is believed that improves the overall efficiency of the system. There are also a debate what we use between the DC and the AC. There are AC microgrids. They are the same. They use the same voltage frequency like in traditional grid. There are DC microgrids that they have everything is DC, so everything is used to be in DC. There are others that are named hybrid, that they have a bus that is DC, or a part of microgrid is DC, other part it's AC. Why it's such a debate is that most of the electronics and most of the appliances, they can operate in DC. The DC system are more efficient than the AC system, so they increase the efficiency, the local efficiency.